Put it in almost.
Oh, time was 5 days ago.
No, the time is this morning. It was very early. So, how many things, presentations have I done?
You're at 9:50?
Okay.
What?
And how many presentations?
About
I
17.
like your confidence.
That it will be at 9:50? Oh, yes, yes.
You are before Yang, so.
Oh, yeah. I appreciate it.
Full house.
Yeah.
Interesting. Oh, shall we get going, given that it's
Yes, and
9:01? Yeah.
Good morning, everybody. Welcome to Routing Working Group meeting at IETF 99 Chicago. We're about to start.
Please consider the note well, which you have probably seen at other sessions. I'm not going to go through all the details, but take note that things that you say here and contribute on the mailing list and general participation have certain implications. So you should look at that in detail to understand those implications in terms of IPR and so on. And we, in the routing area working group, there's general procedures for the IETF as a whole. We, in particular, have a process by which we poll authors about IPR rules related to documents in the working group at each step in the working group process. So we'll do that at working group adoption as well as working group last call. And so the general idea is to get IPR disclosed as early and often as possible.
Please welcome Secretary Yanjin. If you would stand up and show up your face. Thank you for helping us and looking forward.
Hello, everyone. My name is Yingjin. I'm just got this great honor to become the secretary to serve this great community. My very first IETF presentation was done 2 years ago in routing group. And so I will need all your support and help. Thank you.
So, thanks to note takers. Thank you for Jabber. I'll get your name later. Please sign the blue sheets. It's important. We are having two meetings, one today, one tomorrow. The agenda for today is on the screen. Partially normal Rtgwg things, partially young. I would like to thank Anis and Rob from OpenConfig who came here to talk about current status of things, what has been done, and how they work together. So we keep pushing boundaries for our charter. We would like to bring new things. Things are important for industry, things you're interested in. So keep picking us. We would like to extend what we do. Document status, we've got new RFC 8102 on remote LFA node protection. We've got good number of drafts getting ready for working group last call, all of them being reviewed by young doctors, by working group members, by shepherds. I would really like you to encourage you to do shepherding work. So if you are interested, please come to the chairs. There's a number of drafts which need shepherd. So number of working group drafts could go through significant number of them. Again, it's getting to this stage. There are solid documents that we are going to look into working group last call. So number of documents, and I assume we are ready for the first presenter. Would be David Black.
So I'm David Black, and unlike a lot of past encounters, I'm not wearing a transport area hat. Instead, I'm here to introduce some new work. As I noted on the mailing list, a related standards effort over in DMTF needs to do network management and manage to resist the not intended here temptation. They're reusing Yang. What's needed now to help move this forward is a notion of device profiles. And so it's my pleasure to introduce Joe White and John Lung, who are my colleagues who did most of the work, and I'm going to talk about it.
All right, thank you, David. So we're going to talk about Yang device profile for Redfish network management, and in general about how Redfish wants to incorporate networking into their converged infrastructure management story and how we went about that. Okay, so this is in conjunction with DMTF. So there's a working group within DMTF called the SPMF. We love acronyms. And that group is what publishes the set of Redfish specifications. So Redfish is a standard for converged infrastructure management interfaces. Okay, converged infrastructure, of course, is compute, network, storage, all integrated together, usually with a common management plane, often orchestrated. For Redfish, we took a look at doing it ourselves, and we went within the Redfish language scheme and all this, and we started to spec out all this complicated stuff, and then we stepped back for a second and said, wait a second. There's a vast amount of work in Yang. Yang's a perfectly good descriptive language for laying out network devices and their protocols. And so we said, hey, let's see if we can translate Yang to Redfish. And we did. We found a way to map from one language to another, and I'll explain a bit about how that's done. And we also realized that what's really needed to be effective with converged infrastructure is to specify in a somewhat prescriptive way a set of Yang models that if you implement that, you'll work well in converged infrastructure stories. So we start with a baseline switch. There can be other profiles, and we think of them in terms of profiles because that's just a nice industry term for a collection of models and standards that go together. And what we would really like is to reuse those profiles in a wider way within the IETF world, in the industry in general. So we don't see this as a single point profile and we're done. We really want a family of profiles long term. And I think that matches with the things I was hearing in the NetMod working group yesterday. Okay, so let's drop back into a little bit more background on what converged infrastructure is. I'm sure you guys know this very well, but just to set the stage. So server, storage, networking, assemble into a larger system. You think of it together. Composable systems also fit within a subset of converged infrastructure where you can then apportion the hardware within the workloads. And in point of fact, the real work for this started where we were looking at composable infrastructure and the role of the networking and the network management and setup for a composable infrastructure. We widened that out to a more general converged infrastructure story because we thought it applied. Now, if you think about the size of one of these racks, 92U rack or something, you get 1 to 4 network switches per rack. So there are really a relatively small number of the systems you have to manage. Okay? And when you look at this from a systems management point of view, again, you want something common. You want to do things the same way for your systems management approach. But when you go set up the server, that's not the same as setting up all your networking protocols to glue all the things together. Okay? And you grow data centers by adding racks. in a variety of ways, but typically just say, hey, I need more capacity, go install another rack or bring another rack online. Okay, so let's step back again and give you some background on Redfish itself. Okay, so Redfish came about because the major server vendors said IPMI is not cutting it for scale-out solutions. IPMI did not have what you needed in terms of security, functionality, and extensibility to manage the much larger number and actually more complicated devices. Okay? So Redfish was invented to address the shortcomings of IPMI. Okay? And the customer requirements were really, again, single interface, okay? Common way to do things. That resonates with customers. Okay? And the APIs, what you really want to do is take a more modern, HTTP approach, JSON, security that comes with that, all of the infrastructure and modeling that you can get with that. So a group was formed, and then that was brought into the DMTF. The work was brought into DMTF, which formed the SPMF, and many organizations are aligning to that. So you have SNIA, Open Compute, TGG, UFI, all aligning to Redfish. And you see very wide acceptance of Redfish for server management. And I'll talk in a second about storage management. So SNIA kicked off an effort called Swordfish, which is a Redfish spinoff to do SMIS replacement. Okay, so networking is the only piece really missing from this story, and that's why we said, hey, let's do the Yang thing, let's translate it, and now we've got networking, and we can leverage all of the experience of IETF. Okay, but in that, you really want to take device management and systems management seriously. So if I have a network box, what does that network box really look like? Well, it looks like a server actually, except it's got this funny thing on it called a NPU or a packet forwarding engine, or other term for that. So you really want to think about that as chassis, thermal, power fan, embedded compute, those sort of things. Hey, let's manage those in common. And then where things deviate, so for storage, it's all of the storage provisioning and storage resource management. And for networking, it's, you got to set up your VLANs, you got to set up your BGP, you've got to set up your, you deal with your interfaces and that sort of thing. Okay. So how did we do it? Okay, so I've said a few times what we did. The way we did it is we mapped the Yang language into a language called CSDL, Common Schema Definition Language, which was part of an OData specification, which was meant to be an online database management access schema definition. And OData has a sort of an entity relationship model. So you create all these entities, they have properties, and you link them together with references to other things. Okay, Yang is a node tree structured thing with some cross references, but mostly node tree structured. And Yang has a lot of objects in it that look like containers, right? So they have, so the module itself looks like a container. Obviously, a container is a container. A list is, a list of containers and that sort of thing. So what we did is we said if we transform a Yang list into a Redfish collection, we transform leaves into properties, we can actually do this work. And moreover, what we said is we'll embed the network switch or router or appliance at the top level within the schema. So we created a network devices collection to give you some flexibility in how you define things. So if you want to do a proxy and manage 4 switches under the proxy, you can do that. If you want to manage different aspects in very different ways, you could create 2 network devices. We sort of reused the routing working group term there because it fit exactly for what we wanted. And so you can define a number of these things, and then you can put a collection of Yang modules under them, and I'll show you a result of that in a second. Okay, and then you just access those models via Redfish JSON. Okay, so in the end, it's just JSON in, JSON out. So it's actually very straightforward in the end, although you have to go through a bunch of steps to get there. Okay, so the steps you go to get there are take the Yang, map it into the OData CSDL, which is an XML formatted modeling language. And then there's another converter that actually automatically puts it into JSON schema. And we have a prototype of an automatic mapping, so it can be done programmatically. And over at the SPMF, we have a spec showing exactly how you map each of the Yang things. And we did Yang 1.0. Then now you have JSON messages that go back and forth, use your HTTP, and so that part is very straightforward. Okay. So
Can I ask
what
you a quick
is,
question?
yes, sir.
So just Rtgwg.
Yes.
On the previous slide, so how lossy is your mapping to JSON schema? So I guess we've seen a couple of attempts to do this kind of thing, and the thing I observe is that you end up with a lot of loss from the Yang schema as to, you know, it essentially becomes a typed only thing at the end of the JSON schema.
So it's basically lossless. So it's to the CSDL, it's completely lossless. Although we have to turn a few of the constructs into annotations, you don't lose them. So if you understand how to parse those annotations, you can do it. So you know, Yang extension, for example, we have no way to interpret that because there's no context in the spec, as everyone knows. And so we just turn that into an annotation and say, hey, we saw this thing. Here's the spot it fits in the hierarchy. You know, here's everything we know about it. So we have basically a faithful translation for CSDL, and then the JSON schema actually is faithful from the CSDL. So we have Yang to CSDL is faithful, and then CSDL to JSON schema is faithful, although things get rearranged. John, do you want to emphasize?
One thing you'll find is OData CSDL is an OASIS standard, and it is far more rich in its descriptive language than either JSON or JSON is. So the translation from OData to JSON is definitely lossless. And so that's why we decided to map Yang to something very rich schema language.
Do you have a spec for how your JSON schema looks? So I guess you have some annotations in that schema to say like pattern statements and that.
Yes, yes, we do.
Is that, so I haven't read the document that this relates to. So do you, sorry, full disclosure. Do you have a spec for how that JSON schema looks?
Yes, we do.
That would be really interesting to share.
Yes, both the Redfish spec explains what the JSON looks like, and the mapping spec explains how you get from Yang to OData with its various annotations.
Okay.
And the reason we have two schemas, right? One would just think one schema is enough, is that OData is, JSON schema is not a standard. It exists, but only one or two people actually own it. And so we didn't want to build a standard on top of a non-standard. So we went to OData, which is a real standard by OASIS, and built Redfish on top of that.
It would be really useful if you sent all the resources to the routing working group mailing list so people know where to find the schemes and references.
That's right. And they're running examples of this for servers. So there's actually online examples. The SPMF website has a lot of educational material and a lot of information on how this CSDL to JSON schema is done. It shows the resulting things. There are mock-ups online that you can just go probe because it's just go banging on a HTTP, you know, URI. So it's you know, I lose my advancing seems to, oh, there it is. Okay. So here's a little snippet of an example of what you get with this. So there's a Yang model that everyone knows and presumably loves, you know, interfaces. And so there's a little snippet of it. And so you take that thing and you translate it into a set of XML files, which then get translated into a set of JSON schema files. And the resulting JSON message is there at the bottom for just a tiny snippet. And again, you can see the translation spec again at SPMF, and you can see how the HTTP messages look for servers in great detail at the SPMF website. And so yeah. Good.
So I would note in doing the mapping, we did this, most of it mechanically. So what we want to do was preserve all the leaf nodes. So if you notice, all the names are identical, right? So we attempted to fix it, and we decided to abandon all that because it made it mechanically impossible to do it. So you'll see a one-to-one relationship between the leaf nodes and the properties that exist in the resulting JSON.
Okay, and so what we're aiming for is complete structural reuse of Yang. Okay, so here's an example of the layout in terms of the addresses of each of the objects for, say, 7223 and 7317 system. And within each of those, what you would find is a root container, effectively. That's the module itself. And then inside of that, you would find collections and containers following the node hierarchy. And when you hit the bottom, the leaf and the leaf list become properties of an object within the system. So we basically take all container-like things to objects, and then all leaf-like things and into properties, and then we put all the annotations that you could want, and we build the hierarchy of the objects in the CSDL to match what the Yang says it should. Okay, so it's again it is a faithful mapping. So this was the trick that trick. It's not a trick. I mean, this was the insight we had that made us realize we could reuse all the Yang stuff, and that's a good thing. Okay, and so we'll go back, and I'll emphasize the very last bullet. So now we have a separate draft in that says, hey, here's the outline of what we think a baseline switch should be. And by baseline switch, think of a Tor in that converged infrastructure rack that I said. Okay, that's what we want to manage. And what's the minimum spanning set of Yang modules that you would want for that? And we're really looking for help, guidance, collaboration in this effort. Okay. So questions? We're good on time?
Yeah, we're quite good on time. So I had a question when reading this about sort of the comparison between OData and, say, RESTconf. Are you familiar with RESTconf?
Yep.
Okay, and because the end result seems to be similar.
Yep,
in
end
that you
results are
have,
similar.
So it might be good to just sort of explicitly discuss that and sort of, I mean, my take was OData is, say, richer and already being used for a lot of other stuff, and you're already going down the road of OData, and you're not really trying to say, you know, that's already decided, but you saw that the Yang model is a good way to generate that, and it's not really a competition with, say, RESTconf. It's just different approaches.
That's exactly right. Just different approaches. And so RESTconf is perfectly good. NetConf is perfectly good. Other DevOps approaches are perfectly good, embedded agents and so on. This approach is meant to be part of the overall converged infrastructure management story. The one thing this does particularly well is systems management, because the server guys and the storage guys have a lot more systems than we do, even if you take all the routers in existence into account. And we like to think of ourselves as, you know, very important, because we are, because we glue everything together, but we don't actually have that many systems. So if you were going to come at it from a systems management point of view, you'd really like to say, hey, let's do systems management like those guys who that's most of all they do, right? Server builders, that's what they do. I mean, all my colleagues at Dell, that's what they do. So let's do that part that way. And then within that, if you say, hey, if I've got a rack of converged infrastructure, how do I want to manage the networking? Well, I'd really like to do it the way IETF says, but I'd really also like to do it the way the server guys say. So let's marry those. That's really how this came about, and so you nailed it exactly. So RESTconf's perfectly good, NetConf's perfectly good. We've got, I mean, they're all just different ways to do things, and that gives us a lot of choices in the industry for different deployments and so on. Is that?
Yeah, thanks. Thanks.
Okay.
And to put a product spin around it, we started with compute. So currently there are at least a dozen implementations of Redfish already that exist. The spec was released in 2015, so it's fairly fast. In August of 2016, SNIA released the storage models. And so those implementations are ongoing. So we've kind of got compute is almost done, storage is on its way, and we're trying to do networking. And we just decided that trying to build models ourselves was going to take too long, and it was much easier to go leverage the expertise of IETF and bring those models across to get converged. One thing he quickly mentioned was the green grid. So the green grid does does models for managing data center equipment, DSIM equipment. So they've already launched a Redfish API working group to define a Redfish interface for managing cracks and power distribution units and other things in the facility side of the data center. So this the convergence may be more than just compute, storage, and network. It may also encompass the other platforms within the data center on the facility side.
Aaliyah Atlas. So I'm really happy to see this work. I do have a couple questions. One is, as you're looking at the Yang models and what you need, are there features or challenges in integrating the models that we're producing into your framework?
Yeah, some of them aren't done. They're in draft state. And having them be RFCs would help a lot. So that's one thing. The Yang itself has a few things in it that present a little bit of a challenge when you map, but nothing that can't be dealt with. So we could we have a nice long discussion on that in the framework of our other draft, where we're trying to lay out here's what the baseline switch looks like. But mostly it's that the set is a little bit incomplete. People have been sort of doing it on their own, and there are a lot of drafts. So they're like 90 or 100 Yang module drafts, and there's about a third of them are real RFCs right now, if you look, or something like that. I mean, we did a survey, and the numbers are something like that. I mean, we should redo that survey and look again. And the baseline switch draft starts to do that. And if you look in there, we say what some of the weaknesses are, what we're looking for.
Yes, I'm extremely well aware of the fact that we have a number of excellent Yang models that are still in working group draft form. One of the challenges in deciding which models to encourage to move rapidly has to do with making sure that we get a coherent set. And one of my concerns is that we end up progressing a set that's useful, but ends up lacking, say, one or two, which you need for this particular device profile, or for other ones, which I hope we'll start seeing coming in. So hearing what that set is useful, as well as what you actually perhaps need from particular models, because a lot of the models, there's challenges in reconciling what folks want to expose from different implementations to find a good common abstraction. And what one needs, for instance, for service provider BGP is very different than what one needs for other uses of BGP. And it may be the case that that is also the situation for some of the models that you're looking for in this context.
Yeah, that's somewhat true. I mean, that would be a great discussion to have. That's the exact kind of guidance and help we need and discussion we need. So thank you. Yeah, we should continue that discussion. I mean, I don't want to have it here, because if we start to go into that, how much time do we have in this session? So, but thank you. Yeah. Yes, I completely appreciate your points, and there's no criticism in what I said. We just did a survey and just observed what was true. And so what we also realized is that writing such models is challenging, because, as John said, we started off trying to do this by hand ourselves, straight in CSDL. We actually started to write a full switch schema from scratch, and we abandoned that after a while, but we learned a lot from it. What we learned is what we needed and what we didn't need. And also, and actually there are some gaps as well for a separate discussion, like in general gaps. And so, yeah, so it's, yeah, it's interesting. Sorry.
Perfectly understandable. Excellent, even. Thank you very much for bringing the work.
Sure.
So young is,
Are we set?
yes, so young is young, as you know, and growing. So build when you must, augment when you can. So,
Yeah, exactly.
and all your on-site are of very great use because, say, new concept, there's no better validation than having running code. So all you on-site, they're very valuable, and please be vocal and active on the working group list about your findings and challenges.
Excellent.
So I just want to be explicit though, since we use the routing area working group as sort of a way of introducing new work into the whole routing area, as well as we have our own specific work. And so is the general idea for this document to be in the routing area working group? Is that what you're suggesting, or maybe David has a comment on that?
We'll let David, and then we have a question.
Yes, most of the underlying Yang model, a lot of underlying Yang models that we need are here. Makes sense to work in one place.
Right. Okay. I just wanted to make that explicit because we have a lot of drafts that we discuss here that are not really targeted here. Let's do one more question and then we'll move on. Thanks.
Thank you. I'm calling from Huawei. I just curious about. I saw that this approach just input some YAML files and output have some resultant resources, something like the RESTful API. Is that true? So may I thought it's at some tools just like the Young tools in the Honors project. This tool can generate the RESTconf API from the Young files.
Sorry, I didn't get that very last part. Which thing generates?
The approach. I want to know the difference between the Young tools with your Redfish approach.
So why don't we take this one like offline afterwards? I think it's kind of similar to the question about they produce a RESTful API,
Yeah.
just like RESTconf,
Yeah.
but they're using a richer OData standard that servers use.
Yeah.
And but let's take this one
Yeah, so
offline and
again, it's not that there's only one right way to do this job. There are several ways to do this job. This is one, and the profile that goes with it is for coordinating with servers and storage. So do things the same way with servers and storage where it's converged infrastructure. So if I had a core router environment, I might not do this. Probably wouldn't. I mean that's the so there's a split in the way in which you manage systems, right? There are a lot of ways to orchestrate, a lot of ways to manage, a lot of ways to control, and this is one that matches up with existing infrastructure for servers and storage, which is why it has value. Other ones have value for different reasons.
okay, so I'm going to cut off the discussion there, and
Thank you very
because we
much.
need to move on to the next presentation by Jen Linkova.
Good morning. My name is Jen Linkova, Google, and here is update on enterprise multi-homing draft. So, obligatory slide, which I copied from my previous presentation because I do not want to go into details about the draft because it's just an update and we had a 40 minutes talk in Berlin. So basically, Okay, so basically what problem we are trying to solve? Enterprise networks which do not have their own address space and would like to use provider aggregatable address space might have problems with multi-homing in V6 because there are actually two different parts of the problem. First, when network routes the packet, it needs to send it to correct ISP based on the source address. Because obviously you cannot send in general the packet with source address from ISP address space to ISP-B because hopefully that ISP might implement BCP38 and ingress filtering. So this should be solved on the network level, obviously, and for this we suggest using source address dependent routing. But there is another problem. One or more uplinks could go up and down and so on, so some of that address space might not be actually usable on the particular time. Or a network administrator might have policies and they might want to prefer particular uplink. So we need somehow to tell the host which source address should be used. And the second part of the draft is basically talking about first hop router and host interaction, and how network could give some guidance to a host about desirable behavior, which source addresses should be used and which source address should not be used at a particular time. So draft actually has been adopted by the working group. Thanks a lot for support. So changes made since the previous version, changes made since adoption. So we changed intended status from standard to informational. We added clarification text about do we actually need any changes in standard behavior. The good news is we do not need to change anything on the host. It's not in scope of 6-month at all. The proposed solution is would work on any host which implements recent, like reasonably recent standards. Yeah, I'd say reasonably recent because to cover most generic case, it would be great if hosts support the full source address selection algorithm, including rules which were optional till recently. Because the most recent multi-homing host RFC says the host should support rule 5.5 of default address selection, which actually allow us to implement quite tricky scenarios in instructing host which source address to use. So generic solution relies on source address dependent routing. So that's why this draft is here, because it's all about routing. But the good news again is that some quite simple but common scenarios, like just two internet uplinks, when one is backup or primary, or it's actually load balancing, we can actually do it right now with some not very elegant dirty hacks, but that it actually would work even without source address dependent routing. But it will be really nice to have SADR on routers to make it easy to configure and easy to support. We provided more details again why DHCP-v6 is not a good option. The more I think about it, the more reasons I keep finding. And also clarified split DNS scenarios, because actually in generic case, different DNS servers provided by different ISPs might give you different answers. So this needs to be taken into account as well. Changes to be made. It was a comment about what could be done on the protocol levels, on the host stack to solve this problem. I'm actually glad to see some other work being done in that area. We can talk about MPTCP or how quick can survive source address change on a client. And there are some work done in multiple provisioning domains and so on. However, this draft is more like tactical solution on what can we do now. Because as a network operator, I control the network, but I actually do not know what people bring into my network. With all this bring your own device, guest network in my office, I have no control over it. It might be quite old device, which has quite old operating system. And I provide service which I would like almost any host to use. And I would expect, even with all these new protocols and new solutions coming, I expect a long tail of old hosts, which I still would like to support. And again, the goal is to have a solution which would work for most of the hosts and network could provide some guidance to host what to do, and then host indeed could, if host is smart enough, host can make its own decision. Actually, that's it. I would like to see some comments, suggestions, what we shall do.
So I have a comment more as a co-author. We originally wrote this because we'd gotten a request from V6 Ops to sort of solve this problem, but we didn't have a very good framework, at least for people in the routing area, to really understand the full end-to-end context of the problem and the general solution that I think a lot of people had in their mind, because this problem's been floating around for 15 years or so. And so this is like a framework for the general solution. And there are several other documents within the routing area, both in this group as well as the IGP groups, that work on the source address routing portion of this. And so it's a framework. I don't think we should necessarily progress it immediately, because I think we want to sort of have feedback as those other initiatives go forward. So I don't see a necessary, this is just my opinion as a co-author, not as working group chair, that it would behoove us to use this as to incorporate issues that come up in those other working groups on those solutions. But that's just my opinion as a contributor.
Robert Rtgwg. So I have one question. You started the presentation saying that this is applicable to enterprises which don't have their own address space. True. But shouldn't we encourage enterprises to get /48, 32, to get it from registry and have it?
No.
In general?
Okay, my scenario, I have an office with 10 people. Shall I give them /48? Shall we give every small location /48? Oh, some people would love it because then you have to get more and more equipment on the network and add more and more memory, right? We'll inflate routing table, and it just doesn't look actually reasonable. I do not think every I don't know, a coffee shop should have their own /48. From my perspective, yeah, I do not. And actually, another scenario is, in this case, you assume they will run BGP, right? I have scenarios where I have 2 DSL connections for those people sitting, 3 people or 5 people sitting in the office. They would not run BGP. So we need to solve this problem as well. But they do not run BGP, but they do want to have multi-homing and redundancy.
No, sure. I meant for, let's say, coffee shops. It's a Starbucks block. Not each coffee shop has 48. That's one thing. Yeah. But it's applicable for smaller guys, like maybe, as you said, 2, 3. So I'm not saying it's a bad idea, right? I'm just asking more general question for enterprises who can get a block.
No, I think those people do have their own blocks, right? But in some scenarios, you still want to have local ingress, right? Instead of tunneling having your own address space, tunneling everything to your head office and send traffic there. You might want to use provider address space to simplify to improve user experience.
Yeah, Joel Yegley, I think the distinction is an entity, whatever it is, I mean, however small you want to describe it, embedded within another prefix which you already carry, or does it have its own prefix? It's irrelevant how big or small the prefix is, whether it's embedded inside another entity or is on its lonesome. It is what drives whether it has a prefix or not.
Jeff Oz, I think one of the things that might be a way to sell this a little bit better is you're sort of going over, this is what happened if you have real internet-wide multi-homed address spaces that you want to actually use and not use something like BGP. Where I think this use case is a little bit clearer for most people in the existing context is you have more than one address space, potentially internal to your enterprise, For example, a VPN network and the public internet, where you actually want to be able to have people at their hosts use the appropriate network. And the same problem is, it's exactly the same problem.
Yeah, it might be, we might consider it as a use case. The good thing, if I have internal address space and I control the network, it's slightly simpler because I can allow them to use ISP address space as long as I know that address space, right? Because we kind of might simplify the issue of BCP38 in that case, right?
Right, and first hop NAT of some sort actually solves this sort of problem, but that means that you're effectively running NAT right next to the host, and that's sort of gross.
Okay, we'll stop here. Fabrizio?
Good morning. I'm Fab Devatek, and I'm going to talk about a project study that I have been working on with Sanjeev Kapoor, a professor at the Illinois Institute of Technology. The motivation that led us to start this project was that, of course, that the internet traffic is growing and the bandwidth requirements are exploding due to new applications and services that pop up constantly. So there is a need to maximize network throughput when new facilities cannot be added to the network. And one obvious solution to that is to use multipath routing, so using multiple paths for the same packet flow. But we looked at some of the existing multipath routing schemes, and we found that we could use more elasticity to manage congestion more effectively, to address fair allocation of resources so that some users are not penalized by congestion on some links, and preventing bottlenecks. Sorry, wrong direction. Other direction. Oh, okay, thank you. So we call our proposed solution dynamic multipath routing. And with this solution, we discover new paths dynamically during taking into consideration the situation in the network. We improve throughput. We improve the management of congestion. And we also ensure a level of fairness among different source destination pairs. So we have investigated two methods. The first method provides congestion control by rerouting dynamically flows based on network conditions. The second method has the same congestion control as the first method, but it also adds a fairness enforcement to make sure that every user of the network gets a minimum percentage of the required or desired demand. So both methods have certain items in common. They use an additive increase, which is used to gradually increase the packet rate gradually reach the desired packet rate. Multiplicative decrease, which is used to cut back on the packet rate dramatically when congestion is detected. And then we use a combination of source routing and link state routing, which is essentially OSPF, although in the tool that we use, it's not called that way. I'll explain maybe that later. And we modified the link state advertisements of OSPF by putting in queuing delay and adding queue occupancy. So here are more details on the first method. It's based on congestion of a path's length. It's a variable b that has a value between 0 and 1. In practice, as I'll show later with our simulations, we use the 0 when there is no congestion, 0.5 when one link of the path is congested, and 1 when more than one is congested. Now, the algorithm is that when there is congestion, you can see the equation there. The flow on path I at time t is uses that factor 1 minus bi, where I is the path, and uppercase T is the cycle time. In other words, we refresh the network situation at cycle time t. We use the cycle times of 50 milliseconds or 500 milliseconds. We also, at the end of each cycle time, we also find the shortest path based on link delay. And if the shortest path is new, in other words, it was not on the multiple path list, we add it. And then we apply the additive increase in case the demand is not reached at that point. But we apply that only to the current shortest path. And at the bottom, you see the equation that shows how that is applied. The method 2, in this method, we added the management of fairness using that. Oh, I'm sorry. I have to apologize. There is a typo there. We use a combination. We still call the factor BI, but this time it's a combination of two components, PBQ and PBF. PBQ is the same as in the previous case. It takes into account link congestion, which in our case, for our simulations, we used 80% queue occupancy on the outgoing link. And PBF is the fairness. So I have to apologize here. PBF should be 1 minus that ratio. So I apologize. To use a common expression, if you do the math, you see that without the 1 minus, it wouldn't work. And gamma is the fairness coefficient. That is the minimum percentage of the requested or desired demand that we want to ensure. And then you can see how the effect of applying those factors, how that works on the flow on path I at time t. And at the bottom, you see the equation for the additive increase in case the demand is not achieved at that time. Here, more details. In order to prove, study the results or the feasibility of this method, of these two methods, we used a simulator that is called NS3 that allows you to simulate a network and provides simulation for routers and nodes that can use UDP or TCP and so forth. In both cases, as you remember from the previous slides, we use this factor BI, which in case 1 is based only on queue occupancy, and in method 2 is a combination of queue occupancy and fairness. And then the factor A is a flow increase, and in our simulation, we used 500 packet per second as a additive increase. For source routing, we used a tool that is available in the NS3 simulator called next vector routing, and which we modified slightly. And then for finding the shortest path, we used the version of OSPF that is provided by NS3. They don't call it that way because they took some shortcuts in distributing the LSAs, but for the rest, it follows exactly the RFC for OSPF. We modified that also. For link cost, we use queuing delay, and we also added a few bits to the LSA to include queue occupancy, the percentage of queue occupancy.
2 minutes.
And so for the simulations, we used multiple users, typically 20, starting at random times. And we also have a set of background traffic that is stable. So these are the results of the simulations. And so offline, if you're interested, we can go into the details. Conclusion is that we can show through our simulations that throughput is improved, and fairness is improved, and we need further studies. And this is only the beginning. It took a while to get the NS3 simulator going. We need to figure out what is the total network throughput, how to reduce the number of paths. On some of the solutions, we have a number of paths that could be considered a little, maybe too high. We need to introduce packet acknowledgement because in our simulations, again, we use UDP, so a datagram system. And we need to investigate if there are best methods for source routing in beyond the next vector that we used.
Any questions? So I would like to thank you for sharing your results here. It's valuable research. As throughput grows, goodput reduces, as we all know. So it would be great to see you maybe next IETF after, when you've gathered more results and there's more data to analyze. Thank you. Kirati?
Hello, I'm not here because I want to be here. I'm here because people made me come here. So we presented this at the MPLS working group, and I think it was Stuart, who was back there somewhere, but said that we should present this at the routing area working group. Yes. Yes, yes. Okay, so this is basically a fairly simple thing. To protect LDP, we have many methods, but we decided we need one more. So basically, you can do link protection and node protection using RSVP paths, and that way you're not forced to go by the shortest path, or worry about loops, or worry about U-turns. Remember those? There is no restriction on the topology so long as you can compute a path from the point of local repair to the merge point. And you can use things like SRLGs and stuff. So the idea is that this is very, very simple to configure. And basically, you're creating bypass LSPs like you would for RSVP protection, except you're doing this for LDP. To do the node protection, you'd need a targeted LDP session. For link protection, it's very straightforward. So there's no new standards or no new things being done here. It's really just a, what's it called, best current practice kind of thing, where this is being used and it's been implemented, and AC is going to ask me something.
Yes. This is really just the description of the technique commonly known as LDP over RSVP, right?
No, 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 no.
It's not.
It's
something
not.
new. Okay.
Yeah. Well, for the protection, it'll be LDP or RSVP.
Yes. Right. Okay.
But the goal here is not. It's for protecting an LDP LSP, and there'll be a picture soon, so we can see there. But it is. Just it's one solution to the problem of protecting LDP LSPs. There's also a synergy with MLDP. So for MLDP, if you want link and node protection, you could use a very similar method.
Ron, don't lose that iPad. It's mine. Is that going into minutes? Okay, so here we are with link protection. So the red lines are LDP LSPs, all going to this egress R7, and the dotted lines are RSVP signaled LSPs to protect links. So the link R1 to R2 is protected by this green dotted thingy, and so that's the point of local repair, and that's the merge point, and similarly for these. So all we're saying is that I can create an LSP, a TE LSP that will protect this link, and I don't have to worry about, what would the shortest path be, or how would this work. The more interesting one is node protection, where, for example, I have this LSP, and I want to protect the node R2. And so in order to do that, I'd have to create a different LSP, which could be signaled with RSVP TE. That would essentially go to R3, which would be the merge point. This is a case where it's intra-area. When you go to inter-area, it gets a little more complex, where if you're trying to protect R3, which is an ABR, then you have to find a different ABR going into the same area. So, so the merge point would be this guy. So basically, this has been explained, and these are very straightforward methods. We did this in the MPLS working group. I'm bringing it here because the authors wanted to make this a working group document, and so there needs to be an arm wrestling match between you and the MPLS chairs, and whoever wins, this is the prize. So yeah, this draft has been stable for about a year. Version 5 addresses all the comments we've got so far, and so the authors, which I'm not one of, would like to have this be a working group document.
So is this informational or standard?
I think it should be a BCP, but because
Okay.
there's no new standards here.
Right. So
Oh, Aliyah?
okay, yeah, either so informational or BCP, whichever kind of.
Yeah.
BCP has a certain like higher level of connotation to it, I guess. But
Oh, yeah, one of the reasons that I think this draft is better suited to Rtgwg is because of the interactions with, for instance, the microloop forwarding problems that we have, or the interactions when you talk about protecting an ABR, you have the same type of complexity that comes out with LFA or remote LFA
Yes.
for doing those computations. And that's the type of review and expertise that the draft will get noticed in those kinds of perspectives.
Plus the background that, this is where we do IP/LDP protection. So yeah, I'm good with that.
So draft is new to working group. Would be great if everybody could read it and provide their feedback. Again, it's not how you do it, it's what you do and how to configure it. So it's meant to help service providers, people who are really the consumers of the technology.
Okay, thank you.
Thank you. Lou?
Hi, I'm Lou Berger. I'm talking for the routing area Yang architecture design team. Boy, is that a mouthful. We have a bunch of members. The ones in bold are sort of signed up on the on this presentation. There's some other members. If I say something that they disagree with, they're welcome to come to the mic. But just note that just because they're members of the design team doesn't necessarily mean they endorse everything I'm going to say. We have a whole bunch of topics and more than we have time for. And they're sort of ordered in the in order that the design team thought was important to cover. But we included also some examples of LNE and logical network elements and network instances that this group has talked about quite a bit. But we know it's important. The chairs asked for some more examples. These will eventually make it into the document. If you look through the examples, you'll see the slides. They look really simple. Not at all. There's a whole jumble of information. We understand it's a complex topic and it is confusing. We'll try to improve the document as best as we can to clear up any, to help it easier, make it easier to get through the material and to understand the concepts there. If we have discussions on the list, that would actually be helpful because that will allow us to make sure that we get the text right. So if you have questions, send them to the list. We'll try to clarify and the discussion, and then capture the discussion in the documents so the next person that comes along after the documents are published can understand it as well.
So if you could state the new directions as decided during NetConf meeting, I think it would be very well. We will be kind of reiterating the decision, and Benoit's in the room.
Okay. I think you're referring to topic 2, and I have a slide on that.
Yes.
So we'll get there, and if I don't say what you're looking for, ask me then. So we sort of start out with 4 items, and there's been some additional requests of what we're doing. There's the overall device model work. There's worrying about revised data stores, conventions, and model classification. The real point of this slide is actually the part that is grayed out, is to point out what we're not doing. So the design team was asked to look at a couple of different issues, and right now we're not taking them up, and so I guess that's opportunity for other people in the working group. This is the regex. One is the regex discussion that we're going to hear about. I assume we're going to hear about in a little bit. The other is that there are some important routing area Yang models that are expired within the area. And I think there's a interest to revive these documents, but we're not taking that on right now. So it's an opportunity for others to take on work. If you're interested in contributing to those Yang efforts, I suggest you talk to the routing the chairs about which documents these are, and also the AD about it. Okay, so we started out with something called the meta model or device model. That's now been translated into 2 standards tracks document. One is the logical network element. This is to do things that are logical systems, virtual systems. And the next one is network instance. This is to support VRFs and the bridge equivalent VSIs, virtual switching instances. Both are gated by and use schema mount. Schema mount is being discussed within the NetMod working group. The work we hope will be wrapping up very quickly, but if you were in NetMod, you will see that there's some points that still need to be worked through. And there's likely to be a virtual interim on that topic in the next few weeks, maybe the next month. If you are interested in implementing support for VRFs, VSIs, logical systems, you might be interested in attending that because it's going to impact you. We also have a informational model which sort of lays out the structure of how models could relate to each other in terms of their logical functions within a router. We, at one point, were looking at imposing that structure in a hierarchy of a module hierarchy. And that was really rejected by the community, and we, after that was rejected, said, yeah, that makes sense. But we also think that having ability to indicate whether something is a routing protocol module, an IGP, or let's say a signaling protocol, having that type of module metadata is useful information for the user. And our current approach to solve that problem is using something called tags, and we're going to talk about that in a little bit. We have an individual document on that that's going to be presented in NetMod, the NetMod session 2. It's not going to be a big presentation, but if you're interested, I'll tell you a little bit about it and you can read the document. So on the schema mount side, there in the document, there's 6 issues that are identified as being open. I think a lot of the discussion in NetMod was just sort of basic understanding pieces. And we only got to, I think, issue number 2 before we realized that there was no way we're going to get through the issues in the allotted time and that we really needed an interim to deal with them. Some of the issues, it would be very good to get the perspective of folks here, because you're the users of Schema Mount, and you'll be the ones implementing support for it. And it's really important that whatever the mechanisms we define, even if they're sort of generic mechanisms intended for all users, it's important that our users, the routing area users, provide specific feedback on the utility and usability and supportability of these functions. So, like, I'm just going to go into one example, the one that was talked about in the NetMod meeting earlier this week. But we have a pointer here somewhere. There we go. There's a point where there's a place where you can use this mount point extension to identify where the mount point exists in the module. But that same information is also available somewhere else where you provide additional control. And there's a question of, do we put it in both places? From a technical standpoint, we really don't need it in both places. But from someone who's going to go implement a module or is reading a module, having that mount point identifier in your schema tells you, yes, this is where your VRF ties into the rest of the system. Without it, you have to go read another module to figure out that the VRF ties in a different place. I think that's a little confusing, and having this optional information element provides a lot of utility to users and implementers. The flip side is it's an extra piece there, it's an extra structure. Is it really needed? And maybe it's redundancy. Maybe we're going to cause some conflicts when things don't open up. So there's a little bit of a trade-off there. It'd be good to understand from people using this whether or not they think it's important. So it'd be good to look at the draft. It's a NetMod draft. Here we go. Schema mount. Look at the open issues, and if you have opinions on it, send it to the working group list, or participate in the virtual interim that'll be coming up as soon as it can be scheduled, say 2 to 4 weeks. What's going on with OpState? This is a very hot topic. We've spent a lot of time on it in the IETF. The discussion was started by some folks who are in the back of the room. It's now been translated into the revised data store work. I assume most people are familiar with it at this point. From a design team standpoint, we're not really actively doing anything other than waiting to see where it comes, or when it comes, and what it looks like. What we are thinking about is how do we transition to it? And that's going to be like the next part of the talk, where we're going to spend hopefully a good chunk of the time, and Shufang is going to lead that. Routing types, we have an update on that. In the sort of the interest of time, I'll cut to the chase on it, which is we want to know if the working group thinks that we have the right set of information there, and whether or not it's ready to last call.
So I assume all the comments from IGP and IDR have been addressed, right? So all common types are there.
Okay. So I'll flip through that, and then we'll get to that slide, and I'll ask the question again. I mentioned that we have a draft on tags, on the metadata to identify a type of module. The idea here is that you can go to a server, query in a couple of different ways. We have a couple of different options that we'll talk about in NetMod, but we can query the device in a couple of different ways and say, give me a list of all control plane protocols that you support, routing protocols. Any type of metadata that, one, is identified from a standards perspective, or that a user wishes to associate with a module. So as a user, you can not only query, you can also set. That's assuming you have the right privileges, and that would probably be a installation time thing. So if you want to flag something as this is your service model or this is a specific customer related model, you can do that with this approach. I'm going to flip through this pretty quickly so we could spend more time on the op state transition discussion, if that's okay. So there's a new version of the routing types update. While I'm a co-author, most of the work is being done by Shifang. So right over there, you'll hear from me in a moment. Basically, we want to have a common place where the types that are used across the area are defined. There's been some renaming that's been done from the last meeting. I think that's pretty straightforward. We also have some new types and groupings. Basically, at the last meeting, we said if you think you have something that should be common, tell us. We've had some good offline discussions, moved in a number of types and a couple of groupings. At this point, we think it's important for the document to be wrapped up. I think it was on, I don't know. There was a slide that showed who's using it, but I've lost that. But this is being referenced now by a number of other modules. So it's rapidly going to turn into a gating document. The question is do we really have any other types or groupings that we've yet to identify? And if so, are they that important that we should hold up the document? The authors feel that it's ready to go. And so we'd very much like a feeling from the chairs, from the working group, if there's agreement on that. And if there is, then we rapidly last call.
So to my understanding, all the comments from relative working group have been addressed, so all common types are there. I've requested, we have requested usual reviews from young doctors and routing review team. So past that, I think we are ready for a last call.
Great, thank you. So at this point, we're going to talk about, really focus on transition strategies for revised data store. So I think there, in the NetMod group, there was a discussion on what do we do for new models. That's for things that have yet to be started. And there's there was a sense of the room that new models should only support revised data stores. Okay, sure, that's great. That's for new models. There's a whole lot of work that we've been doing. Someone earlier mentioned, I don't know, what was that, 137 drafts in flight. What do we do for them?
So I would say actually it would be useful, given the number of people in the room, to spend, say, 3 to 5 minutes on a little bit of history on this. Does that seem reasonable? Is that?
We spent a lot of time going over that. Now that said, you're the chair.
So proceed as you see fit on this.
Thank you. With that, and that we have 12 minutes, I'm going to turn over to Shifang, who will introduce the topic the way he sees fit. How's that? So I'm passing the buck.
Proceed as you see fit.
Thanks for being ready to go, Shifang.
So, to reiterate, it's not a request to change existing model. We just went through all the pain to split state. So only for new models or models that are starting their life.
Right. So we know the revised data store is coming, and so that's the goal we are moving towards, and eventually we all have the model written for the revised data store. But currently, people are implementing the models, which is using the old netconf data stores, and so what do we do for the current model we are writing? So we think we're trying to make the model can be worked for the current netconf data stores, and eventually can be easily migrated to the revised data store. So then this is our goals, and so we need to have a clear migration path, and we want to have a minimum impact during this process. So have a reference point here. So eventually when the revised data store is released, then the model will have a single tree. So for each leaf, each attribute here, we can achieve its configuration data and the operational data from the same schema and based on different data stores. So this is, if you look at the structure, it's much more compact than current structure like interfaces and the routing. So this is the way we are moving to, but what's the way we have for now? Currently, all the released published model are using this split top level trees. So we already have this proposal ready from the revised data store draft to give us a migration path. The way we do that, see, I'm taking an example here from our existing simplified TE tunnel model. So we have a list of tunnels and configuration attributes and the states. So if we use the split top level trees, we have a model like this. Then when we try to migrate to the revised data store, we need to deprecate the whole tree here. And we need to restructure, add a piece of the information we need back to the top level tree. So here we'll have, for those operational state information we need to add here. And for those already existing configuration leaves, they will have also serve the purpose for the operational state depending on the data store. This process is kind of disruptive, so we probably need to rewrite the model and publish a new document. Thanks to the, I think to the polling result yesterday, it seems like we don't have to go this way. So currently, there's for the tunnel model, where we're using the convention like that. So we have for each entity here, we have a config branch container and the state container. If we use this kind of convention, then when we try to migrate to the revised data store approach, we'll need to do something like that. So we can take out the the duplicate portion of the states. See the protection type and the bandwidth. So here we have a before the revised data store, we have single data store, which means we have this desired requested bandwidth, and this is actual bandwidth. So the two states then eventually will be merged together in the revised data store. So the thing here is that this container, so it's kind of weird here, and it's not maybe misleading, so people may not be comfortable with this. So in that case, we can do another approach here. So which means we have the tree designed with all the configuration attributes listed right under the list items. And here we keep this a state container, which is a duplicate to the configuration data. If we do that, then when we try to migrate to the revised data store, all we need to do is deprecating the duplicate portion. So if we do this, we still have the we can fit this model, right? So for the current data store approach, and eventually can be easily migrated to the revised data store, and meanwhile we can retain the programmability, and so still, yeah, I see Rob's.
Rtgwg. So if we're going to do this, and build a bunch of models that have state containers that duplicate leaves, we have a set that already do this, right? So, and then we could have the applied state and the operational state without needing to implement data stores. So why would we then go and do the effort to implement the data stores? Like, this is a nice solution. I like it. Fine. But I don't understand how this is really a migration rather than an alternate solution.
When the revised data store is available, then this will be unnecessary. It doesn't hurt anything, but right. So
So I'm sitting here writing code. Okay, I'm going to write support for this approach. Great. Let's do it. Great. I'm done. Right. Why do I write support for revised data stores at all if I build it like this? So this is exactly one of the solutions. If you go back like however many years it is now, and look at the solutions that we proposed for solutions to obfuscate, this was one of them. And actually, we proposed both this one and the flip side, where you have a config container and the default is state. I think this isn't a transition strategy. Is the point I want to make? Like it's an alternate solution.
Like to hear from others.
So, Christian Hops, T-Systems. I think the next slide is real, what you're talking about.
Okay, let's finish that, and we can come back to talk about the. So here, another option here, right? So if you don't want to have the duplicates, then we just do the model like that, without the states at all. Then, so here we have the configuration attributes. We have some additional states. We have statistics. But here, what we missing here, so we cannot have the desired and used states for the same attribute. And we cannot have intended and applied. So then if we do here, then we'll, when the revised data store comes along, we just automatically gain the additional capability. We will have the information for the intended data store and applied configuration and also actual operational. So that's, then we don't need to do anything. So eventually we'll have the same model we can use for the future, but for now we'll have limited capabilities. For some model, this may or may not be issue. So for some models, so we're losing some kind of capabilities here. So then, okay, so those are the options. So then we should pick a way to for the current model, right? So if we want to have an easy way to migrate out, like even Rob said, we just pick one of those models as our final solution. We don't need to worry about the even deprecation or so republish anything. So.
Lou Berger.
Yeah.
Lou Berger. So I think Rob's question was really as much, is there value in the revised data store approach, or what value do we get from the revised data store? Maybe this is really what Chris wanted us to talk about before jumping into the options. It's a fair point. So from my standpoint, we want to be able to represent the information that is what is set for from a configuration standpoint, and be able to retrieve information of what is happening operationally, and do that in a way that's both clean and requires the minimizes the amount of redundant schema we have to define. And that's what the revised data store approach allows us to do, and then also gives us a framework. Rob's not even listening. Hey, Rob, Shakir, I'm responding to you. It's all right. So, is that better? So the intent is to derive some benefit here in terms of how we design and build our schema. And yes, you can question whether or not the revised data store solution is a good way to do that or not. I think the consensus in NetMod as it is, having discussions from this group about whether it is certainly interesting, because here are the users, and users are important, right? But let's presuppose that we are moving to revised data stores. What do we do in the interim? Do we wait for everything to be done there so it's shipping and available on all the equipment, and do no models and freeze everything until then? I hope not. I think everyone else hopes not in this room. And so what's the best way to get there? And so why are we doing any of this or having any of this discussion is because we don't want to stop doing work in the next months, maybe longer, until your equipment supports the new revised data stores. Hey, it's not even defined yet, so they are not, it's going to be a while. So we'd really like to continue doing useful work, but we also don't want to make it hard once we do get this model, the eventual solution that we believe is the right one. So that's why we're doing it, to answer your question.
And this is a dialogue open to all the stakeholders, so please be vocal. Show support for one or another option, and we are listening.
Oh yeah, Atlas. So the NetMod, the milestone for the revised data store is very soon. And it takes a fair amount of work to thrash models, and we keep having changes. Can't we set a target that's the revised data stores are coming, let's all work towards that? Is that what you're looking for? Because we want to get these models done, and I understand the don't make people wait, but making people knowing that the changes are coming has its problems too.
Rtgwg, but I would point out that there's a really weird juxtaposition of two things here, because you're blocking implementing VRFs on schema mount, which is again something else that it doesn't work in Yang 1, so it's a bunch of extensions that we need to go and write that functionality to even support VRFs. But then we're pushing forward really quickly, or we want to push forward really quickly on this solution because it's gonna enable something else. What I'm really confused about in the IETF is we're just inventing more and more features that people then have to go and write to be able to do something. If you wanted to really get operational experience and knowledge, 2 years ago we presented how this could work. So let's be realistic about when this stuff's going to come. It's 2 years down the line. There are some shipping implementations of something we proposed a couple of years ago. The revised data stores are not coming tomorrow. They're definitely not coming tomorrow, because the amount of code that you need to write to support this is it's not non-trivial.
Do you mind flipping to the slide that has the summary of the options on it at the end? So I think, Rob, you're really arguing that you want one of their transition approaches. One that has the operational information together, the state, together with the config. So we have a couple of options that include that. So that's, actually, I think 1, 2, and 3 all do that in different ways. And it's almost optimization, which way is the best way to deprecate it once we get to the actual solution. But all of those approaches do what you're saying, I think, just in different ways. Number 4 is interesting because, and I think Chris talked about this in NetMod, is that there's a whole lot of models where actually you don't really care what the intended versus the operational state is. And the ambiguity there is okay. And in those models, you can just do the eventual solution. So let's say that you have a whole slew that you can just go implement what's the optimal. And between now and the time you have revised data stores, you just don't have that information available. Well, it doesn't really matter because you didn't care about it in those cases. In the other cases, pick one of those other options. And the question for the working group is, which of those other options do we want to sort of adopt as a convention in the routing area? So we're definitely not saying don't do anything. We're saying let's agree on which convention we're going to use in the interim. So which convention do you want? I know.
Because containers called config and state. Yeah, I think, is this mic working? Okay, so Rob, just to ask you, when you objected earlier, you objected it was don't switch to a new version that looks just like the old version. Right? I mean, so the option you're going to pick would be the one that you guys picked. And let's not change that for our models that we picked to go that look like that. And I think that's reasonable, right? Right. I'm just pointing out that we're like thrashing out exactly the same debate that we spent N hours of interim meeting on already, right? So that's how you define it.
Shifeng, I have one clarification question. When we augment from T-tunnel model, when you use this revised data store, would that impact the sub-young models that augment from this model? How does that impact? Because we have a lot of young models that are pending on T-topology and T-tunnel model, and I want to hear that the impact would not be there when you augment.
Right. That's the reason I come here. So because before this week, we were told probably we need to do the split tree like this. So if we do that, there will be a big impact to us. We have to rewrite the model now, and in several months later, we need to rewrite again. So that's something I don't want to do. So that's why we put all those options here, so that. But since yesterday, I think this approach is totally dropped. So we don't need to worry about that. So any of the other approach, we don't need to have any do anything extra for our augmentation. So for your T model, we are fine now. So
that's great to hear that. Okay.
Shifeng, just to be clear, can you put up what you think is the right way to go? Which works?
If I would do, I probably would do this. Let me see, this number 3. This way.
Jeff, I think the reason why we're having this debate over and over again is that there is no one right solution, because some of these things work better in some circumstances and some don't. So the example is, if you have your operational state is largely segregated anyway, you don't need a magic mount point for all your operational state. And in the cases where your operational state lives alongside your configuration state, as long as your configuration state is not redundant noise, there's no reason to separate it then either. So this isn't so much there is one right solution. There is several right solutions based on how things would likely be structured.
So my proposal would be to finish with this presentation, have Anis talking about GNMI and gRPC, and then we move into 40 minutes block to have exactly the discussion.
Just AC Linda, just one quick thing to add to what Jeff said. There are a number of people writing tools for RESTConf, NetConf, and Yang, and there are wildly different opinions on which of these models prior to revised data stores are present a better programming model. And so you don't, and the people representing these different views will come to the mic and be adamant about just diametrically opposed organizations.
And where we are as a design team is we would like to see if we can come up with one recommended approach of what to do in the interim within the routing area.
Absolutely.
And we don't want to end up with where Jeff was leading, and actually what the current state is, where you look at your model and figure out what's best for you. And we were hoping we can get to one, and that's why we're having this discussion. And I understand you want to table this discussion.
So AC, I've only seen one person get up, open config. I mean, I would love to see other people if they have different opinions, right? But so far we have the operators that are driving this are, you know, the limited amount that I bring to the table from DT and open config. If there's people with other opinions, they need to get up and start expressing them at the mic, like you said.
So we cut it after, Alex, please keep your comments till the last block, okay?
So, Benoit Clay, so I missed a couple of interventions because of the mic over there. So what is the conclusion here, or you want to table that for after?
There are options, and we would like to come to a consensus which option seems to be the best one and supported by a majority of the participants.
So you'll get to that later, or?
No, definitely not today. Today, options are presented.
Okay. So when will it be done then? So are we going to discuss this at the next meeting, or is this like in
Hopefully
the meantime?
before.
All right.
We'll work with the working group and probably cross-post with your area on our decision.
Okay.
Just make a very quick remark here actually as well, because we're facing exactly the same issue in conjunction with the topology models. So same type of things there, and actually we are actually it would be great to have a consistent approach there. And actually one thing that we also decided actually based on the discussion yesterday would be actually to go to revised data store, to the revised data store solution there in that context.
So the end goal of the discussion is to come up with a single approach to do and no further rewrites.
Right. So this
hopefully
one would be,
even
this
Rob
would be
could be
consistent.
happy with it. Hey, hopefully even you could be happy with it.
At least from my point of view, though, it's going to be a recommendation of a single approach as opposed to a mandatory. If someone feels differently and is writing the document and convinces their working group to do it, then more power to them. So get up to the mic and argue with me then.
We'll come after your family.
Right. Oh, yeah. So the lovely thing, on the one hand, yes, I agree in the sense of having strict rules that ignore the details of the technology is not productive. On the other hand, if you let everyone program in their favorite language, you don't actually end up easily with things that interoperate. So I'd prefer to hear, which is to say, letting engineers pick exactly what they want to do without having reasoning that helps pull it together doesn't work so well. So I'd prefer if we are able to come to a recommendation that if there are models that don't want to follow that recommendation, that there be some technical rationale that we can use to make that judgment call. It's not a free-for-all.
That's fine. I think like 90% of the people working on these models do not care what the answer is and just want direction. And for the other 10%, we can deal with that.
Lou Berger. The thing we want to avoid is models that depend on each other, like we were just hearing about it with respect to topology and TE topology, that they end up making different choices and then thereby not being aligned. Yeah. And maybe we can't reach that wonderful goal of having a single approach and a convention across the routing area. By the way, we recognize that we failed at the last IETF. We said we couldn't do that across all the IETF. So now we're trying just inside the routing area. But let's say we do fail to come up with a single recommendation. Maybe we say for topology models, we do this. For tunnel or signaling models, we do this. For routing models, we do this other thing. So at least we have some consistency across our types of models. I see Jeff nodding his head no, so we'll see what happens.
Could you please keep it till the last block?
Do you want me to not go? You cut the line ahead? Is
Yes,
that-
please. I
Okay.
cut it
No,
10
that's
minutes
okay.
ago.
Jeff, that has to happen. Good cheer.
So if you could spend 5 minutes going over examples and yes, absolutely.
Okay. All right, so the RNA example here. So this is just how what the logic.
I think we were planning on skipping these. Unless you want to give us another 10 minutes to go through.
5 minutes.
I mean, let's do that quickly. Okay. So we have logical network elements. Then we put together with the schema mount, RNE model, routing, and OSPF. So also interfaces together, see how it works together. So we have, so this is a implementation times of the schema. So we have this view at top level. There's logical network elements. And we have a schema mount here, mount the few modules here, in, library interfaces and routing. So routing, it's a separate module, and we augment that module. So with this OSPF here, right? So we have top level RNG, and then routing, and then in OSPF. The interfaces have a mounted module here and the top level module here. So they are available for this logical interfaces and at the top level. So this is a model. And when we get to the configuration data or state data, then we have all the data follow this tree. And the important thing here is the interface, because that's the way we need to have the mapping. The interface ETH0, ETH1. The ETH1 is assigned to this RNE, so we have that map to the local interface data tree. So this is available for the routing and OSPF. This OSPF instance 1111 can have access to this ETH1 interface. And this is an implementation mapping. So you have two instances, one at the top level, one at the logical elements level. So the naming may or may not be the same, depending on implementation. Then we have beside that the schema mount schema, and also the implementation need to provide the information how this schema mount is mounted. So it's used. So we have this static mounting data, so which shows for the schema mount for this logical network element module, we have a mounting point root mounted by this schema. This schema contains multiple modules here. We have interfaces, interface here, routing here. Then we also have this library. So library need to contains all the necessary modules. So this is here. So put them together, we got the schema we want, and we got the way to retrieve data and configure the device. Here we particularly is OSPF as our example. Right, so we have all the libraries including the mounting schema mount module and the OSPF and all the others. So network instance is a little bit different. Instead of the mount, right? So this is the schema mount. Here we have this we call the reference, right? So parent reference. So here, if we do this way, we mount the routing, and the interface here actually is not fully mounted. This is called what they call parent reference. So here, this schema is borrowed from the parent, and the result of that will be we don't have, even though we can access the data here, ETH1, but that's not a separate instance. It's borrowed from the parent level. And all the other aspects are very similar. So the augmentation and the OSPF instance configuration are the same. Then here, there's a little bit different when we specify the schema mount data. So we have here, we only have one module here mounted. It's IETF routing. So we have a parent reference specified here. Or here. Where's the parent reference? Anyway, okay. Then we have the similar kind of library data and putting together. This is how all the pieces put together.
Thank you, Shupeng. Anis? So, two following presentations are for information only. Thank you for sharing.
All right, so to be more explicit on that, we use the routing area working group as a forum for new work, both in the routing area working group, but also in the routing area. And so the drafts we're talking about here, we don't consider as potential drafts for adoption in the routing area working group, but we're using this as a more open forum.
Okay, with all those disclaimers out of the way, let's get to the information part of the informational drafts.
No slides for gRPC, right?
Yeah, so these two topics are closely related that I'm supposed to cover. So I didn't actually prepare slides for both of them to spare you. Just a quick update on the gRPC use cases draft. So we wrote a draft last year about how gRPC, which is an open source RPC framework that Google open source that's since now been sort of donated or put into the CNCF, which is the Cloud Native Computing Foundation, as an open source project. It's based on our internal microservice communication architecture called Stubby that's gone over 4 generations of work. Now we've open sourced the latest version. We're also using it internally. It's a framework that's built on top of a bunch of other standards, including HTTP2. It has a bunch of nice features that are covered in the draft. I encourage you to go have a look. gRPC has now been adopted by parts of the networking industry for the purposes of network management. So in the use cases draft, we talk about how gRPC can be used for monitoring, using streaming telemetry as a new paradigm for doing monitoring, getting away from the polling-based approaches that we use with SNMP or TL1, and also for configuration management. And just before I move on, I'll point out that there are several implementations available today in the market that actually are in shipping code where gRPC is the protocol that's available to use for both monitoring, that's for streaming telemetry, and also for configuration. So the update to the draft was just to add some new references to actual specifications of how gRPC can be used in the network management context, and that's what the GNMI work is about. It's really a new specification for how to use gRPC for managing network devices.
To my count, there are 7 implementations shipping today, gRPC.
Yeah. So I'm going to go pretty quickly because I want to leave enough time for my colleague Rob to talk also about some of our experiences in implementing this stuff. So I'll start with just what is GNMI in the first place. So GNMI stands for gRPC Network Management Interface. It's a specification basically of what an RPC service would look like on top of a gRPC to provide network management services. And it's essentially focused on managing state on devices. So it's for both manipulating state or modifying state in terms of configuration and also retrieving state using streaming telemetry or to get snapshots of state back from a device. As I've said, it's built on open source gRPC. So gRPC and GNMI aren't the same thing. Think of GNMI as a service definition on top of gRPC, which is providing the underlying RPC framework, which, by the way, is built on top of standard technologies like HTTP2, TLS, TCP, et cetera, et cetera. We've tried hard to design GNMI not to be too specific in terms of what kind of data it carries. So in particular, we really have 2 primary requirements for the data. One is that it can be structured in a tree, and then it also can be addressed using paths, like file system paths, as well as attributes. So we have a fairly simple syntax for how we express paths in gRPC. It looks a lot like XPath, but it has some simplifications. And the data should also have a well-defined serialization to put out onto the wire. So we are using it initially for Yang model data, but it's not required that you have to use Yang in order to use GNMI. So what motivated us to look at GNMI as an alternative approach to network management? First of all, it's a consolidated service. So it's providing services for both configuration management and for streaming telemetry in terms of monitoring. We built it on top of what we think is a modern protocol. It has lots of built-in support for things like bidirectional streaming with HTTP, binary framing, channel multiplexing, lots of nice things that we benefit from by building on top of it. It has a very efficient serialization. So what we found is that when we start to look at streaming telemetry in particular, getting very large volume data back from devices, think of things like the routing table, for example. We find that the ability to have binary framing as well as a protobuf-based serialization really has a bunch of benefits in terms of efficiency. The gRPC team has published recently a bunch of new benchmarks on both performance and sort of efficiency on the wire that I would urge you to go look at on their website, which is grpc.io. And it's an implemented standard, so it's an implemented service rather. It offers an alternative way to manage devices. So we have things like netconf and resconf that are emerging standards. We also have now GNMI as an alternative. So as Jeff pointed out, there are a bunch of implementations. Some of them are shipping, some of them are available as early release from numerous vendors, both in the routing and switching space as well as in the optical transport space. And we have a bunch of reference tools that have been published under the OpenConfig umbrella to use GNMI. So a couple of additional disclaimers after our chairs. As they pointed out, this is an informational draft. So the normative reference for GNMI is really the spec that we publish on GitHub. It's just a markdown document, and that's the most recent and should be considered the authoritative spec. We really wanted to share some information with the rest of the IETF community about some of the operational requirements and design considerations that have gone into GNMI, and also make the community aware of other network management technology that's work that's being done outside of the IETF auspices. So although we published GNMI as part of under the OpenConfig umbrella, which is OpenConfig, for those of you who may not know, it's a sort of loose group of operators, engineers, and architects from different network operators that have gotten together to define a set of data models for network management, both for configuration and telemetry, as well as tools and software and other specifications. So GNMI has been published under OpenConfig, but it's not the standard OpenConfig management protocol. So in particular, we have operators in OpenConfig who are using netconf and resconf and other things, as well as those who are interested in GNMI. So I think, as I was discussing with Lou in the back just a minute ago, OpenConfig is really focusing on a common set of data models, and at least our philosophy is that there should be flexibility in terms of which transport protocol or RPC framework you want to use. So for the rest of the talk, I'm just going to go through a little bit of high level about the service itself, what it looks like, just to give you an idea of some of the things that you'll find in the spec. The service itself is very simple. We use a semantic version for the service like any API. We make changes to the API as we get new learnings from deploying it and using it with vendors. The semantic version indicates changes that are backward compatible or incompatible. As you can see, it's a fairly early version at this time, although we do have implementation. So 4 basic RPCs as part of the overall service. There's a capability RPC to interrogate devices to learn about what's supported by the device. The get RPC is basically to get snapshots of state from the device. Set RPC is to set configuration data, so to basically update configuration information. And then subscribe is primarily used to get streaming telemetry notifications from the device. So you can subscribe to paths in the data tree, and then there's information about how you want that data to be returned, and the subscription results in a set of notifications that are streamed back from the device. So this is, as you can see, highlighted in red, the subscribe RPC is a streaming RPC, so it maintains an open channel where data can be streamed from the client and also back from the device. So GNMI is based on a few kind of base message types. The first is a path. We encode paths. As I said, we address data in GNMI using paths that are encoded essentially as an array of strings to make it easy to parse them. It's a simple array of path components. As I said, GNMI paths are a sort of simplified variant of XPath, and we have actually a companion document to the spec that gives examples of how paths are expressed in GNMI. We've gone through a lot of debate about how to express paths and lots of different ideas there. I think we've finally gotten to one that works for both implementers and for those writing NMS clients. The data is transmitted as these values. The value today encodes byte string as well as, or byte value as well as an encoding. GNMI has a few defined encoding types. Today you can see sort of base JSON, the IETF spec for how Yang model data is represented as JSON is also specifically called out. You can send data as protobuf natively, as well as ASCII. So one of the reasons that we've kept ASCII is as we migrate to using model-based management, obviously we don't have data models that are supported natively on every device out there. So GNMI also supports what we call mixed schema management, where you have some data that's sent based on, let's say, a Yang model schema. We have open config models, and then the remainder of the data may be based on a different schema. That schema could be the vendor's proprietary data models. It could even be ASCII CLI, and we have the payload able to carry data together that has both data from one schema as well as data from another schema, or from something like CLI or Proto. And then, of course, there's sort of an opaque bytes encoding as well. We have a canonical error message. We leverage gRPC's canonical error codes for this. And then, of course, there's some additional informational fields for carrying error feedback. So I'm only going to go through, I won't have time to go through all the RPCs. The capabilities RPC is very simple. Today, it just interrogates the device to find out about what models it supports and what encodings it supports, as well as what version of the service it's running. So as you can see, we've tried to be pretty conservative in our initial versions of the RPC, not adding everything that one could think of, but sort of some of the base things that are needed to interact with the device. The model data message here is intended to be based on data that comes from something like a Yang catalog. If you attended the NetMod working group yesterday, we discussed the work around the Yang catalog. Benoit and the team have sort of built a prototype of the catalog you can go check out. So the idea is that the model data that's returned by the device would have some references to entries in that catalog to give you information about where to go find more data on the models. The set RPC is also pretty simple. A set request consists of basically multiple operations that can be sent together as a transaction. So the spec defines all of the requests that are part of a single set request, or all the operations should be applied as a transaction. That is, they should all succeed or all fail. And then the response contains a response for each operation that was submitted. So it's this repeated field of update result messages that carry information about success or failure of each individual one, and also an overall success or failure. So you can know whether you need to check for responses for each individual operation or not. The subscribe RPC is sort of the main RPC we use for streaming telemetry. I haven't listed all the messages here. Basically, you can send a subscription that has multiple paths in it that can all be specified using different modes in terms of how you want the data to be returned. So GNMI defines 3 basic modes for streaming telemetry data. One is that you want this data that you specified to be returned at a certain frequency. So this is the sample mode. There's data that only should be returned when it changes. So think of things like events, interface going up or down or changing state, etc. Those kinds of things should be sent to you on change. And then there's this target defined mode where the device actually can decide how best it should send the data. Some data is naturally well suited for periodic streaming. Some data is naturally well suited for on-change or event-based streaming. So the target defined mode gives the device flexibility to choose how it wants to stream the data. And the subscribe RPC itself at the top level supports multiple modes. So the sort of canonical mode is streaming. So that, in other words, the device will just continuously stream data once it's synchronized with the client. The other modes we support are a polling mode. So you can actually fall back to sort of a poll. So it indicates that you're still using the streaming RPC, but you're sort of sending requests at some cadence. And then finally, a get once operation. So the difference between a get RPC and a get once is that with a get, it's just like a standard poll that you would do today, where you're asking for some amount of data that gets returned as one snapshot. With the get once operation over the streaming channel, you basically are issuing the same GET request, but the target has the flexibility to stream the data back to you as and when it's possible. So this is a lot less burdensome on the target in terms of needing to buffer all this data, create the snapshot, and return it all at once. This way it can sort of paste the data that it returns back to you for that, if you're asking, for example, for a very large snapshot. Each of the subscribed responses mostly consist of notifications. There's a few different types of responses that are described in the specification. These streaming notifications come essentially with a path that indicates, for example, there might be a notification that a data item was deleted, so we just have the path and the delete, and it has, of course, a timestamp associated with it. So the spec defines the timestamp semantics to be the time when the data was sampled by the device, and then the client has an accurate view of when that data was generated. And then finally, I'll wrap up with just a few words on what else we're doing with GNMI. The current definition that we've created really only supports a model where the NMS or the client is sort of connecting into the target. There are use cases though when you want the target to dial out to an NMS or to the client or the management system. So there's some extensions required for that. Right now it's very it's defined in terms of specific client and server. So there's some extensions needed to enable the reverse target initiated connections. We're also working on standardizing a set of, or defining a common, let me not use the word standardizing here, a common set of operational commands. So GNMI is really focused on state management, configuration and monitoring. Things like ping, trace route, clear BGP session, reboot the server, those kind of operational commands are also things that we've found lots of people asking for sort of a common way to do that across devices. So we're defining a companion service. It's actually a set of microservices to GNMI that we should be releasing a first draft of very soon. And then finally, working on a native protobuf value encoding. So in other words, how we can carry all the data, for example, in a Yang schema as proto. So a canonical generation of Yang to protobuf, which would be obviously very useful in GNMI. So I'll stop there, and if there's any questions or comments, happy to take them.
My name is Rtgwg. I love what's going on with gRPC. I'm glad to see GNMI coming up because it has a lot of the functions that we've been looking at over in the NetConf working group, about a dozen of us. We've been looking at how to do it over NetConf, over HTTP2, and over RESTConf. I guess my question is, we'd love to get some of the work we've been doing there working with gRPC. Do you have any thoughts, or maybe this is a question for the APs, how do we get the work that's been going on with the subscriptions over in NetConf working with gRPC so that we can reference it as an IETF spec?
Since we have lots of ADs here, I'll let ADs answer first.
Oh yeah, so we know that there are different ecosystems that are interested in using Yang models as a common point of interoperability and doing different types of subscriptions. We're talking about possibilities around gRPC, whether that's, but it's not a trivial. One possibility is that it goes to the independent stream to document and then be something that we can reference. But there's some, there's process nuances. So, Benoit and I are talking about it.
So I agree with you that in the end, it's about the modeling and whatever the protocol or the encoding, we might have different ones. So is this only for our information, or would you have any willingness to just have a standard out of this in the IETF? Or you're simply telling the way we work is GitHub and that's it? Because actually we're changing the charter in NetConf, right?
Yeah, so I think one of the changes that I saw that was planned for the charter was to expand it to be other management protocols for carrying Yang model data.
Exactly,
right?
yes.
So this might fit the bill, although as I said at the beginning, we haven't necessarily defined GNMI as a protocol only for carrying Yang model data.
Understood.
Right. So at this time, we haven't really come with the intention of standardizing GNMI in the IETF. It's something we could consider later on. We've talked with both the gRPC team internally. the team of folks who've actually defined this. I think there's openness, but I think, as we've said on many other occasions from an open config perspective and also from our personal perspectives, we need a lot more operational experience before I think it's ready for standardization. As you can see, it's pretty new. We're just now getting implementations and getting experience. We've made a bunch of changes actually to the definition based on some of that experience in terms of finding ways to make the data encodings more efficient, et cetera. So I think we have a bit of time before we would want to consider standardization. We need to get more experience.
If I may cut the line, we've got one presentation to go, and it includes a lot of valuable data for everybody here. So we can take it to the list potentially. Ali?
Before we go, can I finish my earlier question? I would love to see if we could get a group working across the last 3 IETFs at NetConf. We've asked for assistance with making this work over gRPC, and we just haven't been able to get any engagement. Can we have a list, whether it's managed by this group or another, where experts doing gRPC and NetConf are able to come to a common set of requirements?
As Leah said, there's an ongoing process. We are trying to figure out what's the best way. There's definitely interest in gRPC, and there's probably less known fact. Intel implemented gRPC as part of SPDK, which opens a lot of new opportunities as well. So
can we get a community going?
yes, that's the intention. There's enough interest in the industry to do so. So definitely. Thank you. Rob?
So Jeff came by Google a few weeks ago and asked me to talk a little bit about our experiences working with Yang, which have been long, I guess. We've been not as long as, I guess, a bunch of folks, but I wanted to kind of give a bit of background about what we're doing in OpenConfig and some of the challenges we've had, some of the decisions we've made, and just kind of share some of that data. We started around 2014, summer of 2014, as OpenConfig. It's, as Anis kind of said, it's a loosely coupled group of operators. We're focused on defining an operationally viable subset of the configuration and state of routing, switching, and optical transport right now. We've published a bunch of Yang models. They're published via GitHub. We have a release process that goes from a private repository to a public one. And we're focused on implementations by network equipment vendors and within operators' NMS stacks. As I said, we've kind of asked to give a bit of feedback on our experience. We're not asking the IETF for anything right now. We're just sharing some experience. So what have we actually built? We're published right now at the latest count 72 Yang modules and supporting developer infrastructure for that. So that includes a bunch of CI around them, a bunch of style guides, validation, linters, etc. We've got coverage for L2 switches, IP routers, IP MPLS routers, optical transport devices, ROADMs and terminal devices. We publish some Yang tooling. We've published a Yang compiler, which is in running Go. It's called GoYang. We've got Python and Go language binding generation and validation backends. So the Python tooling is open source right now. The Go tooling is, as soon as I fix a few outstanding issues in it, will likely open source as well. We have then a bunch of plugins for Martin's Piang tool, which do various things like generate documentation, extract paths, generate alternate representations of the schema that some of our tools use as their internal way to, rather than passing the Yang directly. And then, as Anis just presented, we've looked at the protocols around the models for configuration and state manipulation. So that's GNMI. We've published a specification and the protocol for that specification. So both the code artifact that you need to build the service from the gRPC library, as well as a spec for how the protocol should work. And a reference collector implementation. We're looking right now at how we, that's for a telemetry collection, so the other side of the subscribe RPC to the device. We're looking at what more of that we are able to open source and build into a usable artifact for the community, rather than right now it's quite tied to some of our internal tools. Some more details about implementations. We've got a number of major vendors that have implemented the OpenConfig models, both for the telemetry use case as well as for configuration manipulation. We interact directly with those with those vendors. based on which members of the OpenConfig community are interested in interacting with them. So essentially, it's a customer-driven interaction. So whichever operator in OpenConfig is interested in said module, and with whichever vendor, we have participation with them. We have a set of private GitHub repos that are used for issue tracking against those, and we iterate based on the feedback from them. And that feedback's been super useful for, we're not just publishing models and saying, hey, this is exactly how it's going to work, but iterating on what's implementable and what makes sense across different vendors' implementations. The models are also used in multiple vendors' NMS stacks, so we've got them operational inside Google, of course, and then another set of operators are also using them to generate their configuration. You can see kind of growing ecosystem around the models as there's more people raising issues against vendors, raising issues with tooling, etc. And as per the feedback we gave, I think in Dallas, we're trying to inform the Yang discussion with running code and try and at least have a bit of experience there. So our model landscape is relatively wide. So we have this kind of top-level virtual idea of a device, and then we have a network instance model, so that includes routing protocols and various entities that can be within a VRF essentially. We have a policy module, we have an auth module that supports routing protocols, BFD, interfaces of course, a set of modules that kind of do some L2 protocols, so LSCP, LLDP, platform module, which is really a container for the overall hardware specification of a device. It's a relatively flexible module to be able to support different layouts of devices. A system module that does authentication and system services, DNS, NTP, etc. An ACL model, we have a QoS model that we're in the process of finalizing. It's currently going through a bit of iteration. And then we have a set of modules that support optical transport. So these are use other modules and pull together, but they have the specific data in it that supports optical devices rather than the IP boxes. A couple of key observations. Folks really don't care that you're using Yang, right? It's like we're very focused on using Yang, but nobody really cares, right? The people who are interacting with devices really want to do something with the device. They don't really care how they do it. They'd like to do it efficiently. They'd like to do it programmatically, but they couldn't care less that you've modeled it in Yang. So, and our philosophy is really kind of tries to support that. We try and make sure that the people who need to know Yang are limited to the people who are writing schema modules. So, and that's more difficult than it sounds in terms of how you get the code artifacts that people are interacting with to look more like something that the people expect to use in their code normally. So for Go, we've been through actually a couple of iterations as to how do we make developers feel like they're not having to specifically think, oh well, this is Yang model data, so the data structures work like this. And for Python, I've been through quite a lot of the same exercise. So that's really our kind of key observation about Yang is that the fewer people know that you're using Yang, the better. Consistency is really key in these modules. So we've had an interesting set of experiences trying to explain to people how we've laid out our models and making sure that that's consistent across every single module. It's really difficult if you're going to say, oh, well, LACP works like this, but LLDP works like this. So that's one of the challenges we've had, and getting people unified around the single approach that we said. There's already been some work. I think it would be very difficult to do it if we had an inconsistent approach. And really, at that point, you would be trading the complexity of multiple vendors, CLIs, for the complexity of multiple models layouts. So we really want to avoid doing that. Yeah, and this word consistent is something I guess I'm going to say quite a lot. One of our colleagues would tell you the top of this slide, and I've been told this multiple times, it's everything is state. So we kind of think about things in terms of where those operational variables sit alongside the configuration. We've talked a lot about op state. I'm going to gloss over it because I don't want to get diverted. The consistency about where it's found is important, I think. We don't want to explain that per model. But the interesting point here is that actually designing the data models really needs to think about the telemetry that you want to get back from the device as well. So things like if you have a keyless list, how do you send a delete for that, for a single entity in that list? If you have to send the entire list, then the list is large, like the rib, you probably don't want to do that. So we've had a number of things where we've thought about, or we've iterated models based on, actually, for telemetry reasons, we probably want this, no matter what the transfer protocol was, but for efficiency, we probably need this kind of layout. We've looked at how we might design the model such that data that's naturally updated together can be transmitted. So like in the LSDB of both OSPF and ISS, what would be updated by telemetry at the same time. And then we've looked at annotations around the schema. How do we indicate to the server what is different data type? Right now, we kind of have that laid out as operational variables versus configuration and ones, which I think there's more that we want to look at here to say, to be able to say things like, is this a variable that you expect to be periodically updated, or with a cadence-based streaming, or is it something that should actually be that should be sampled? The most difficult models that we've had to build are those that unify other data models. So I think there's the kind of experience with the routing modules in IETF as well. The kind of baseline specs are really difficult to get right. We've been around this a few times. A case in point is this network instance model. This is kind of the model that unifies all of the protocols together. So we have the protocols, so normal routing protocols, FAFTs, which is what we're calling a representation of the FIB, the abstract forwarding tables, and then tables for ribs. The functionality that those modules need to provide is also pretty critical, right? Because there's a bunch of things that just configuring an individual protocol doesn't actually let you do. So, for example, route redistribution is kind of a tricky one to do, but it's part of the minimal viable set of things that you want to support for it to be operationally useful. So we found that actually tackling some of those things head on and not punting on them has been critical to usability. It's also non-trivial to map these unifying data models to underlying databases that vendors have. We've been through we've been through the pain of like mapping our network instance model to vendor CLIs to say, well, actually, this is how we think it maps, and we have that live in our network right now. So we think that the operational experience that you get there is pretty critical to figure out, actually, can you do that mapping? It's not really a paper exercise. A few observations about data models. It's not about the best data model. We can spend a long time kind of trying to figure out what the best way to represent things is, but really that you can get pretty stuck up on that. So we're trying to concentrate on operationally usable modules, so making sure that we cover the set of features in the way that they're used rather than how they're specified or how they look on the wire. But also focus on implementability. So we have some duplication in the models of, like, if you look at the BGP model, we have things that are supported at a very granular, like per peer basis, but then things that are then supported at, or per overall routing BGP instance. And there's some duplication in the model, which when you looked at it and said, oh, well, this doesn't look natural. You should probably choose a way to configure this. But actually, for implementation's sake, having both of them, where the implementation only supports the really granular one and one supports the global one, is pretty critical. And we have some mode flags. So path selection in RSVPTE, we have some flags that specifically say, hey, a device might support this mode or this other mode. And the normalization there is really the network design, right? So you choose as a network designer which way you want that to work, and then that becomes the compliance unit for what the boxes that you have in your network support. But for implementation in the shorter term sake, we have this kind of duplication. And we don't really discover some of these issues until review and implementation time. So we have both our private engagement, where we basically go through configurations and look at how they map into the open config model, but also then engagements with vendors, where we talk about, okay, how this would map to the underlying database within the implementation. This is kind of incompatible with publish and then implement, I think. It's also not about the most complete data model, so we can get very hung up on, hey, we should have all these leaves in, because to get the thing usable, then we'll need this set of functionality. But the implementation effort is really leaf by leaf. So the reviews that we do with implementers, including our internal ones, is like specifically walking through every single leaf and talk about how that will actually map into the underlying schema. The obvious thing to point out is the more that you put in the model, the harder it becomes to implement and more work that is. So we're biasing really towards, well, what's the set that we need, and looking at how extensibility will work such that we don't spend all our time looking at kind of niche features that aren't necessarily used by a large set of operators. The bias there is clearly towards operationally used things to avoid the ocean boiling exercise of trying to model every feature in BGP. We found that versioning is also more complex than the revision statement. It's as I've kind of pointed out in NetMod yesterday, we're multiple major revisions into some modules, which means we didn't get it right the first time. We cut 1.0 when somebody started implementing it to kind of maintain some level of consistency in that model. But as soon as we have to make an incompatible change, we're obviously bumping that major revision. There will be backwards incompatible changes as part of the iteration. It's not really possible to avoid them as far as we can see, because the usability of the model becomes significantly impacted. If you get the naming of a leaf wrong, or if you used a name and it turns out that you'd modeled it entirely wrong, then that's kind of tricky to avoid. The revision, the problem that we have with revision is it doesn't really give any information as to what changed within the models. This is just a new revision. It doesn't really tell you whether there was a backwards incompatible change, whether actually we spotted that we made a typo in a description and we wanted to bump the patch version. Versioning gets much harder as we get to combinations of models. So the network instance model, for instance, now has, because it imports 10 or so other OpenConfig modules, then the versioning of it is the kind of cross product of those different models. So the approach we've tried to take is semantic versioning within the models. So we have a document that describes our semantic versioning approach and how we bump majors, minors, and patches, what changes we expect to do that. We've tried to think about the impact to code generation, not just as well as the impact to data instances. So for instance, changing a leaf that was a union that had a string and an int in, and just changing it to be a string, we've tried to say, okay, that's actually a backwards incompatible change, because code generation probably thinks about the fact it was a union in some cases, like in proto one-off. So that's a field that contains multiple values, kind of akin to a union. We have a data structure that we actually generate for that, so we have a similar thing, similar kind of idea as to how that would look in proto as it would in Yang. We've defined this idea of release bundles, where we're saying these set of modules are known to work together at these particular versions with wildcarding for those versions, and then we have feature bundles that are really what we're starting to think of as compliance units for the models. So obviously not every operator needs every path, so it's a way to be able to say what paths are supported where, and say to a vendor, here's what you need to be supported for, say, this particular role in my network. We've also done quite a lot to constrain the feature complexity of what we use in Yang, because there are a lot of degrees of freedom in Yang. You can write lots of Yang lots of different ways. Some of the things end up overlapping. You can achieve the same thing by with a choice or case, in some cases, that you can achieve with a when. Code generation has to consider all of these different things. There are some fun things which, like unions of unions of unions of unions, are always fun to deal with. Unions of multiple enumerations, like so if you have a union that has 2 enumerations within it, how should that look to a developer? It's kind of, it's not clear what the right thing there is. It makes things more complex than we would like. You have defaults that apply to one of n different member types. You have to figure out exactly what type you should figure out. You should represent it and figure out how the developer uses that. Things like presence, how does that naturally map into a data structure that isn't XML? It kind of ends up being that you have some flag that say if this is present or not, or you need to be able to instantiate a nil container and then figure out that you needed to serialize that when it's created, when the data instance is created. So it's possible to use all these features. I think there's, that you can justify all of them when you look at it, but having to support them all increases the number of bugs in code and the effort to implement a library. So I would say that the majority of new features that we're adding to the code generation libraries are support for different features that are used in the models that we're trying to pick up. The majority of bugs I get raised against me are for some unknown combination of features that I didn't even think was possible, and it's not really a tractable problem to have test cases that cover all of them. you can try, but what I've kind of ended up having to resort to is just when they come up, merging those test cases back into the code. It's too, it would be too big an exercise to cover the cross product of all Yang features, I think. The other thing that we've tried to think about is from the off how extensibility will work. It's kind of fine to say here's our module set and this one augments this one, but it kind of needs to be clear how you expect those augmentations to work. So we've said the OpenConfig base model should be the operationally required features, those features that operators within the group are using. We have a wide range of different deployments because we have a wide range of different operators. And then we have a kind of stack of things on top of that, vendor deviations for things that aren't supported. So we're encouraging vendors to publish deviations so that we can, if we're generating vendor-specific code or if we need to know what's unsupported, there's a machine-readable way to do that. We then have extension features on top of the base models that OpenConfig itself publishes. So for instance, in our RIB model, we have some features that in the BGP RIB that our internal implementations keep track of, but external implementations don't necessarily do. So we publish those as hey, this is the set of things that a device could support, but it depends on it's not part of the base functionality. And then we have a set of room for vendor-specific features to be augmented into this tree. So OpenConfig and the IETF, what's our kind of engagement model other than me moaning at mics? We're trying to engage in discussions around modeling. It's not really clear where we do that in terms of these overall consistency questions. There's the routing design team, which is looking at some of those problems. NetMod, which has some stewardship. There's here, which has some stewardship of modules as well. It's probably it would be good to kind of figure out how we really want to do that. And we're trying to also bring some implementation experience to those discussions. So like what is actually working from our perspective, what's difficult, but the wide range of modules right now makes it very difficult to understand like what should we even test that code generation against, that whereas we're seeing coherent sets of modules be released by vendors for their specific specific schema, we're not necessarily seeing the same in the IETF where it's like, oh, I could take this directory of modules and then be able to test against it. Oh, yeah.
So just briefly, we have the routing Yang coordination mailing list, and it's fallen into a bit of disuse, but I think that it would be a very good place to try and have these types of conversations because it pulls from the multiple communities, and that was the intended purpose. And it would also be a lovely place to discuss implementations.
We're aiming to progress the modules that we've already published. I think there's some discussion around this. We've published our BGP model, which is relatively widely implemented right now, and our policy module, which we spent a lot of time trying to figure out what the set of things should be. Those we would like to progress in the IETF if the IETF would like to progress them. And then there's a few things that we're observing. So the conclusion to the op state discussion, especially in terms of whether that's implementable and whether it is implemented. The approach that IETF takes to how the models become implementable, I think, is interesting. And then some of the potential fixes for usability issues that we've kind of observed in Yang. So we've suggested for a while this map type because we think it's much easier to map to a programming language than the existing list in some cases. So a list with a key is kind of a map. So we kind of would like that, and having the duplication of keys within the data of the list as well as in the key of the list has led to a bunch of things where, as a user of the module, we get the question of, well, why do I have to set this thing in two different places or whatever, rather than we've abstracted that a bit by having helper methods that say, oh, I want a new foo, and it then populates the key for all of those places, but it isn't natural for in my opinion. There's this POSIX regex discussion. We're seeing that regexes that are supported are not necessarily the standard that Yang's using, which leads to extra library dependencies, which we would like to avoid if possible. And then things like leaf refs between config true and false, and we debated this the other day as well. There's a few things there, so that's kind of just a simple area of things that we'll also observe on. Benoit's walking to the mic, so I'll be scared.
So Benoit, so thank you for this. You mentioned a couple of key truths in terms of modeling, that the model have to work together. And I want to come back to the point about the guidance for a transition. That's something that you have to make it right. And Aliyah is right that, if it's not consistent, okay, we can't impose everything, but it has to be consistent. If the metric is only the number of Yang models you publish in the IETF, that's the wrong metric, right? The second thing I want to mention is that we start to see that the metadata about models are getting more and more important. Which one work with the other one? What is the revision or the versioning, the feature, the bundle, all this. And that's why I like the work we're doing on the catalog part, because that will become key in the process of revising models. You get it right again that we will not get model right day one. We could dream, but it will not happen.
So thank you, Rob. I appreciate you coming here, sharing your experiences, and hopefully we can work together. There's a place to share your insights, and we are listening. We'll take them seriously, and I can assure you you'll see results.
Thanks.
Thank you. I'll see you tomorrow.
Oh, and if the holders of the blue sheets could, oh, I got them. Okay.
Guys, please sign the blue sheets.